Let's talk about going from standard form to scientific notation and how we go about doing that. So, for example, maybe we want to convert the number 2,365 to scientific notation, which is going to come out to be 2.365 times 10 to the third power. Or maybe we want to convert 0.007 to scientific notation, which is going to be 7 times 10 to the negative third. So how do we go about doing this? There's a few steps to keep in mind, so let's get into it. I want to take a quick second to remind you that if I have a number like 9, I can express that with a decimal by just writing it as 9.0, or I could write it as 9.00 or 00, however many zeros at the end, to make a number that doesn't have a decimal, to put it in decimal form, just stick some zeros at the end of it. If I had 1.2, that's like saying 1.20 or 1.200000. Adding zeros to the right of your last significant digit, we'll call it, to the right of the decimal, doesn't change the value. So it's just another way to express decimal numbers. Let's take 3,000 for example, and I want to write this in scientific notation. So the first thing we want to do is find out where the decimal is. And based on what I just said, we can write standard form numbers in decimal form by just putting a decimal at the end of the number and then sticking a 0, or however many we want after it. Then what we're going to do is we're going to move the decimal to the left in this case. We have a very large number, so we're going to move it to the left. And the reason we're going to move it to the left is we want to create a new number that's between 1 and 10. So if I move my decimal place here, I'll have 300.00. So that's not between 1 and 10. If I move my decimal place here, I'll have 30.000, which is not between 1 and 10. But if I move it one more place over, I'll have 3.0000. That is a number between 1 and 10. So what I'm going to do is I will write my new number, 3.0000. And then since we're writing in scientific notation form, we'll do times 10. And what am I going to raise this 10? What power is it going to have? Well, it's going to be the number of times we moved the decimal to the left in this case. So if we count it up again, we went 1, 2, 3. So I'm going to have 10 to the third. And I can write this a little bit neater. I don't need all of these trailing zeros after the decimal. It's really just important just to have one. So we'll have 3.0 times 10 to the third. And if you want to work backwards, right, from the previous videos to check your work that this scientific notation number does, in fact, give us 3,000, well, let's do that. So I'll take 3.0, and I'm going to move this decimal here 3 places to the right, because that's my exponent. So I'll go 1, 2, 3, put my decimal there, and then fill those remaining gaps with zeros, and I'll have 3,000. All right, here's a couple examples. So again, with this first one, 8,000, very similar to the last example. My decimal's over here, and maybe I'll put a 0 after it. And then I'm going to move it to the left to create that one-digit number that's between 1 and 10. So I'll go 1, 2, 3. That's going to give me 8.0000, which is definitely between 1 and 10. So in scientific notation form, this is going to be 8.0 times 10 to the 1, 2, we move the decimal place 3, and it's going to be a positive 3. All right, 120. Again, let's find the decimal, which is going to be over here. I'll stick a 0 off to the right if I want to. And I'm going to move this decimal to the left until I get a number between 1 and 10. So if I move it here, I will have 12.00. So that's not going to work. Let me move it over one more place, and I'll have 1.200, which is definitely between 1 and 10. So I will write this as 1.2. I don't need these other two zeros here. It's not wrong if you put them, but you don't need them. So I'll have 1.2 times 10 to the, well, I move my decimal 1, 2 times. So 1.2 times 10 squared, or 10 to the second power. All right, next one. Again, find the decimal, which is going to be over here. Maybe I'll stick a 0 to the right. And I'm going to move my decimal to the left until I have a single digit number that's between, I shouldn't say single digit, but a number between 1 and 10. So we'll go 1, 2, 3, 4. There, I have 3.45000, or 3.45, we can just call it. That is definitely between 1 and 10. So I'll take 3.45. Again, I can add the trailing zeros if I want, but it's not necessary. 3.45 is enough. And then times 10 to the, well, I move the decimal place to the left 1, 2, 3, 4 times. So 10 to the 4th. All right, 9,100,000. Again, find your decimal place. So that's going to be over here. Stick a 0 to the right if I want. And then I'm going to move this decimal place to the left until I get a number that's between 1 and 10. So 1, 2, 3, 4, 5. If I put it there, I'll have 91.000000. Move it one more time, and I'll have 9.1000000. So our scientific notation of this number will be 9.1. And I moved it 1, 2, 3, 4, 5, 6 times the decimal. So 9.1 times 10 to the 6th power. All right, 701,000. Again, find your decimal, which is going to be to the right of that number. I can put however many zeros I want to the right. Maybe I'll just do 1 to keep it similar as the previous ones. And then we're moving this decimal to the left until we get a number between 1 and 10. So I'll go 1, 2, 3, 4, 5. So here I got 7.01 with some zeros after it. So my new number is going to be 7.01. I cannot ignore zeros that are kind of sandwiched in with other numbers. If I've got a trail of zeros that doesn't end, I can ignore those. But this one here, since it's sandwiched in between that 7 and 1, can't ignore it. It's got to be part of it. So 7.01, and I move the decimal place once, twice, 3 times, 4 times, and 5 times. So 7.01 times 10 to the 5th.